So I stopped recording. I started re-recording. All right. But all right. So let's do this. So last class, I asked everybody to basically make sure that you have data in Splunk and it's coming in from your servers. So what we're going to do is check that. So you get into your work environment. Your boss says, hey, we want to see what data is coming in like literally right now. There are very few times you should use real-time search, but one of the times you may want to do that is using it to see what data is coming in. So one things you can do, so let's say we wanted to see at real time what data is coming in host. So we'll do index equals, and you'll get what index you're looking for. So I'm going to do star underscore index because I know all the students have that. We'll do literally it's just a basic time chart to see, what's coming in. And then up here, real time, relative, and other. So real time is when, data is actually as it's coming in, you're seeing the data coming in. Relative is like whether you want to do relative to, 15 minutes, 30 days, a year from now, or you want to do like all time in the past. So it doesn't include stuff that's still coming. It's just all time from that moment you click all time, takes it from that second all the way back. And then you can also toggle here where you can actually put different time frames. You can put a second in here, 2 seconds, whatever it is, you can put time frame. And then you can snap to the beginning of the hour, or you can say no snap to. So basically, it's like, hey, don't do a 00000 whatever. Just snap at whatever second it is that we have. Go from there, and then just run it that way. I've never really found the business of doing this, but uh, you know, it is there as an option. Let me say the use case, not necessarily effectiveness. Um, then here, of course, real time is when you want to search real time 24 hours ago, and it always goes back to now. So the now flag is basically saying like now, as in every second. So a second from now is going to be now, so on and so forth. So you have these temperatures. So relative is in the past, real time is what's happening from now into the future. Then you have the option to change the date range. So you can search, let's say they wanted something that happened before 2005. So you can do before, and then you can put the date, you can put since, you have the option to modify it here, between. And then this one doesn't give a time range. It basically snaps it to the beginning of the day. So that's what you'll see here. Whereas if you were to put the time range, you can do a specific date and time range in here down to the millisecond level. And advanced is if you wanted to actually do your own specific time frame. So this is like if you wanted to do at now. So this is 24 hours ago on the hour to the now time. You can also switch this to 24 days ago at 1 month, 1 day at the day, 1 month on the month. You can do stuff like that if you want, but that's just another option if you wanted to put that in there.
Why they put in the hyphen in front? What does that represent?
This?
Mm-hmm.
This is just like in the past, so minus.
Oh, okay. So what if you don't put it on there? Does that affect the search?
Yeah, so this is in the past, so you're basically saying, 1 second to now. So it has to be negative because you're looking in the past, because everything that's happening behind you is a negative, right? So you have to have, a negative back there. Because if you put 2-4, that's like 24 hours in the future or 24 hours from now. Does that make sense?
Yeah, it does.
All right, so let's run this 30-second window real time. So now we're just going to look at the data that's coming in now, real time. And then because I did a transforming command, it's going to automatically pipe it into a statistics table. And then what I can do then is now move it to um, something like this. And now I see the data. So Patrick's looks like his is the only um, server that's been sending something within the last 30 seconds, that is, right? So I'm going to stop. So the thing is, when you run a real-time searches, always be mindful to stop the searches. Um, Splunk does kill it, but it's best for you to stop it. Because over time, um, if you have a compounded real-time searches and other windows running, and let's say you were running a search and you forgot that you click real-time by accident for whatever reason, that's going to drain your system. So right now we see Patrick's, MacBook is sending data to us over 30 seconds. So let's see who else is having data sent to us. Let's do a 1 hour window. Let's see if anybody else has something. But that's only Patrick. So it's going to look back an hour, and it's going to look back an hour, and then it's going to try to calculate. So Richard, okay, and then Rufus sent something recently. All right. So then it's going to keep calculating as new data is coming in. All right, so let's stop that, and we're going to look back. Let's see, 24 hours, hopefully. Let's do real time. Actually, do I want to do 7 days ago? No, it's okay. Let's do 24 hours. All right, so let's apply. Let's see who else has some information come in. So we know Patrick already. We know Rufus has his. We know Richard has his. Let's see if anybody else. All right, looks like those are only guys that within the last 24 hours have data that's constantly coming in. So it's interesting. Okay, so this is just my own search. Say it again.
So I have a lot of data coming in.
Yeah, we do.
Maybe it's because laptop.
Yeah, so any activity you do on your personal laptop, it records it. You were doing one event logs, right?
Yeah, mostly.
Your Mac. Sorry, you're not doing event logs.
Yeah, mostly 80 port 4.3 stuff.
Okay. Yeah. So whatever activity you're doing, we're logging it. So, but you're doing no, you're doing a DNS stream, right?
Yeah, mostly DNS stuff. Three-way handshake, all that stuff.
So as long as you're streaming data, that's why your stuff is so high. I mean, any activity you do over any network, I see it. So that's why it's so much higher. So internet based, I mean, whatever website, whatever pages you click on, stuff like that should stream in.
I need to know how to parse them, effectively.
It should be parsed. I mean, if yours is doing DNS stream, it should be parsed. I think it should come in. There's we can go look at it in just a second. So let's see. Let's do this. So yours is Patrick underscore index. Then we're not going to do real time. We're going to do relative. Let's see what we got here. Yeah, so yours is pretty much parsed. Yours is JSON. So JSON by default typically does key value pairs. So JSON is JavaScript object notation. So basically, as you are sending data, it's putting it in this format, and it does a key value pair matching. So count equals to 2, dest IP equals, of course, IP, end time, blah, blah. So that's how it's matching it. So all of this, by default, you don't have to do any parsing. Splunk automatically parses this stuff for you. So
I think those are still the pages that are open on my desktop.
Yeah, so you have got some.
They try to reconnect, I believe.
Yeah, I honestly, I'm not sure. We have to look and explore what you're doing here. Yeah, I mean, you got a lot of, anything network related is going to be very chatty. one of the things that you'll see in your work environments often is your data model that's often going to be used the most is going to be your network traffic data model. So let's make this 100. We don't have that at the top. No, we have to have it. Network traffic data model. Tell me I don't have one. Okay, so I don't have one. So I don't have a network traffic data model, but I can surely install an app today so you guys can see that. So one data model that you often see is the network traffic data model. It's very chatty. Basically, what I mean chatty is that a lot of events are mapped to that because, again, it's network traffic. So anything you do on the network, whether it's internal or external, is traversing your network layer. So that means that, from you clicking to another drive, from you doing something on another drive, all that stuff as you're going wherever you're going is clocked. And, of course, internet stuff is going to be clocked as well. So anything over, whether it's internal or internal internet or intranet rather, or external internet, it's going to be logged. So these are all things that you have to be mindful of when you are creating things like this. And you know,
Can I tell if it's actually picking up data from my other devices on my router?
yeah, you can search for it, but it it really shouldn't unless you're chatting. Unless this laptop is connecting with that other server, then or any other endpoint you have, that's the only way it's going to track it. So if it's, of course, your router, it's probably going to track like your traffic that you're sending to your router to be, sent out. But that's just from the destination. But from whatever happens from that destination on, typically it's not going to be tracked because we don't have that visibility. So we will literally have to have um, Splunk installed on your router or collecting your syslogs from your router to be able to tell what you're doing there.
Gotcha.
So data model wise, data models are essentially a way for you to organize data. So for instance, looks like, so I created a coronavirus data model, right? So basically what I created in here was saying that every time that data that comes in from source equals corona logs, host equals COVID-19 math drill, and the index equals serial analytics. I want you to capture that and make that my base search. So if I were to run this right here, what I would get is a bunch of fields, and including in those fields are these ones here. So what I'm saying is then I want just a small, minute subset of my data to just encompass just this. So when I run index equals serial analytics, it's going to give me a bunch of events, it's going to be a bunch of stuff. But I only care about this source type and I only care about these fields here. So then whenever I run a search against my data model, it's much faster because it's not looking against all the subset of data that is everywhere in either the serial analytics index or belongs to this specific source. All I care about is just stuff that, while it is, part of this source, host, and index, it has to include this information. Anything else that doesn't include this information in it, I don't care about it. Just omit it. It's not something that's important to me. So what I do then basically say, I want you to extract these fields. So when I do a search, your search is going to be much, much faster than it normally is because I'm only running a search against, let's say in your environment you have 10 billion events. So now I'm only running a search maybe against 5 million events versus 10 billion. It makes it much faster. So that's what data models basically allow you to do. You can group uh, fields together, and you can make, basically a specific like tree about whatever specific data you're looking for. So if you're looking for all hacker data, you may do index equals my network traffic, you know host does not equal any, you know, uh, well, you want to do that, but let's just take an example. You say host equals anything that's that's external, that's communicating to my internal guys, and over a port, 443 or 80 or 22 or whatever it is, and then source type equals, hacker data, whatever. So then what it'll do then is look across all your data that's inside of all your indexes. And as long as it has that source type and then it has, the specific criteria you've matched it to, what it's going to do then is basically gather all that stuff, make basically like a little subset of data that you can look against now. So it's like literally branching it off and say, hey, this person only wants to search against this small, 5 million logs versus this 10 billion logs, so that they can look for anything that, hackers are trying to do in their environment. So that's the gist of data models. The other part about data models is, you see here that there's, matter of fact, let's do this. Let me do a search for you. So let me see. So you have desktop IP, source IP. Should I get a search that would be some bytes, some packets in? Are there some packets in the same? This is packets in general. So let's do this. So what we'll do is this, right? So let's table source. Is that how it's spelled? Yep, source IP. Then we're gonna do some packets in and out. Some packets out. So we're just tabling all this stuff for us. And then looks like it has a few more things. There's values flow. Is there anything here that's the same? Nope. So everything's pretty unique here. So that's fine. All right. So now we table this. So now we looked at, some packets in, some packets out. So let's say we had hypothetically, right, we have another field called, packets in. And we're going to say that packets in actually is going to be equal to basically packets in. So we're going to do so in order for it to be included as a field, you have to put a single quote when you have a parentheses, when you have something surrounded by parentheses. So now we're saying basically packets in is going to be exactly as some packets in. It's the same things, packets in. So you may have fields like this. So you may have something where, user is equals to a capital user, or is equals to a lowercase user, or whatever it is. So this is where data models become effective, is that you can say, now that I have, some packets in and I have packets in field, I want to basically map everything in my small subset of data to only include one or two fields, or these specific fields. So now, instead of including double fields that basically explain the same data, you're just going to grab one field in itself that explains that data. But let's say even packets in may be what describes this information that we see as some packets in another set. Let's say that, the index was, Timmy's index or whatever. And then Timmy's index has a data set that has literally almost the same thing, but the field name is called packets in, but there's no some packets in there. So what we want to do then is say, in our data model, everything that has packets in is what we're going to care about, is what we're going to include now in our data model. And then if for some reason, let's say this guy, some packets in, was in here alone, but wasn't in, but packets in wasn't in this data set, what we'll do then is say, we're going to include a field called packets underscore in. Then we're going to do a field alias. So what field alias does is this. So let's do this. So let's do. So we're gonna pipe this, Patrick. We're gonna pipe your data into. Prayerfully, my collect command works. I actually didn't get a chance to even look at it. Let's do x equals. Send this to access index. Let me see if that would work for us. Index equals access index. Doggone it. What is going on with this? This might not work for me. Sorry, I didn't even get a chance to look at that. That's not what we care about. So this might not be all right. So this might not be fun. We're gonna do a double search then, if that's the case. Smoke wants to be difficult here. Matter of fact, let me see something. This guy should be configured. If you're not, we're gonna make you some. Yep, you are configured. Yep, you surely are. So one thing I encountered recently is if you're not forwarding your internal events, um, when you do the summary search, it doesn't send that to the summary index um, because it's basically trying to capture this on its own like local local index. So what I mean by that is if I create an index on this prod OpenPath server itself, and I do collect equals whatever I send it to this index, what it's going to do is going to send this to this internal index on this server locally. But if I don't have forwarding enabled, it's actually going to index that locally on this computer. But if I have forwarding enabled, what it should do then is say, I am going to send it to access underscore index. But in reality, all my information is being forwarded anyway. So what I'm going to actually do is I'm going to send it to access underscore index, but it's not going to be an access underscore index that's created on this, actual computer itself. It's going to be on wherever the indexer is at. And in this case, the indexer is at this place over here. I'm forwarding all my events, similar to how you guys are forwarding your events to me. And this is set up, so I'm not sure why in Blazes it's still not working. Unless I don't have it. You know what? That's a good question. Let me see if I don't have access index on the other. And x equals so let's see what indexes we have on here. This might be the reason. So let's see. So let's do 100. Right. So yes, looks like that's the reason. Let's do a. So you see, I try to send it to access index. There's no access index. There should be a summary though. So that's why I don't get why there's a summary. But it's not capturing that from a summary. It's really weird. Let me see if I try to do it this way and see what happens. So I'm going to try a Tolu test. See if it can collect it there. All right, and then we'll do test. See if that captures it. No, it still doesn't. Yeah, yeah. I
Prof, sorry, just to interrupt, right? I'm also trying to run some of these commands that you're running, like the index on the it was to Clovis underscore index. I don't see no information on my own machine.
when you do it on your own machine,
Yeah.
yeah, you won't see that because the data doesn't exist on your machine.
Okay, I see now.
You're forwarding all your data to me.
Yeah, all right, okay, I get it.
All right, so yeah, no freaking clue what's going here. I ran into this issue in production recently, and I was able to.
My other one, my other index.
Mhm.
Um,
Yeah, it's just uber weird. I run that search now. count. So events. Let's see if it, so Tolu test. Yeah, see, it's not even sending it to Tolu test because we see nothing's getting there. You know what? Let's see something also. So let's just say hypothetically, do a big hypothetically here. Created a, okay, so it already exists here. So that's not the issue. So let's do index equals. We should see it on both. So yeah, Tolu test exists on both. So when we collect the data, it should literally send it to both servers. I don't know why it's not doing that. So we want to try to test. We know doesn't have anything. So access doesn't have anything. Main. So let's do a stats count. Index. So we're going to see the number of indexes that we have that are, if there are 2, then we're going to see, then that means that there's both indexes exist on each. So we're going to do a stats count by index. So now we don't care about the ones that are 1. So let's count equal to 2. Now we're looking at all the indexes that exist on both. So Panther West. So some exist in both. And then we're going to do values. I want to see the value of how much data is on them. So in main on both of them, so on the main indexer that I use versus the search head, I used to basically store events locally on this search head because it was a standalone instance. So standalone being that this search head used to do everything. It used to be a forwarder. It used to be a, used to index data. I could search data. I used to do everything on this search head. It looks like I'm generating event gen pretty much on both. And some stuff. All right, so Tolu test. I have no clue why your stuff is still not. I don't think your index is disabled either. Let me try one more index. And if not, we're just going to skip it and go. Let's do index. I'm going to watch this number to see if this number fluctuates at all. So let's do. Let's take away this stuff right now. So it doesn't really matter. Okay, so Rufus's index only belongs on the indexer. So let's see if this number actually changes. Well, it may change because he's still standing. So 315, 471. Let's run this. Then number of events as it comes up. Let's see, so 1081. Again. Nope. Yeah, that's not changing. Yeah, so we're gonna have to do something different. This is probably gonna take me a while to diagnose, but this is the fun part of Splunk, I guess. All right. So what I was basically saying that, let's say, for instance, and let's do Control Y. Score index. Let's do last 15 minutes is fine. And then app UDP, some bytes. So remember my table command, don't need to collect it. So I'm tabling, basically all I'm doing is just putting it in a statistics table, because that's what the table command does, just literally puts it in a table format for you. So I'm tabling this, and I created a new field called some packets in. Well, let's say this some packets in did not exist, right? So what I'm gonna do then is create a field alias. So we'll go to settings. We'll open this in a new field. For settings, then field alias. Then let's see which ones we have created, and I'll show you the many that I created. Administrator. Okay, so looks like this one's in the front end app. I don't even remember doing this, but this one's doing attach size as file size, pen trap. So basically saying field alias, there's a field called product version as the PID or product ID. So we'll do a new field alias that we're going to create. Then we're going to put this in front end app. Then we're going to say this is an arbitrary name that you can call it, whatever you want to call it. So we'll say right, so then the source type, we're going to need a source type that we're going to want to transform. So we'll go to the source type over here. So Patrick source type, so packets in. So we'll grab, let's say we do, what is this? This is stream IP. We'll do the stream IP for this one. So stream : IP. Then we're going to do field alias, which is going to be packets as I'm going to say packets square in. Add another field, some packets out as packets. Let's see what else can we throw in here. And some so we'll then we can overwrite the field values if we want, which literally would overwrite like what the other fields are, but we're going to say no, we don't want to do that. So we'll save that. And then since whenever you create a new knowledge object, it's always going to be private. So I'm going to share this out so everybody can take a look and be all happy about it. And then since this is Patrick's data, I'm going to say it's either going to be me or Patrick that has a chance to modify this. All right. Cool. So now let's save. Sometimes it takes a while to propagate. Hopefully that's not the case because we did that last class and I don't think we ever even got to it. But let's what usually I do is, which may not be best, I usually just log out, log back in. Let's see if that, we're going to do a debug refresh. So debug refresh basically refreshes your modules, the different endpoints that you have on Splunk. So all it is you basically get the URL of your server. And after that, you're going to append a debug refresh. And it's going to refresh. And then what it's going to ask you to do is click a refresh button at the top here. Then basically goes through a refresh node. You typically do a debug refresh only on your search head because you have knowledge objects like alerts, reports, um, field aliases, field extractions, things like that that you have modified. But typically, they don't require restart, but they do require for it to be spread across. So what debug refresh or replicated across, what debug refresh does is basically says, hey, let's refresh that now, so that the new stuff that's been changed, if it doesn't require restart, let's refresh it. So then it tells you basically the different endpoints that have been refreshed. You can see down here, these are just a bunch of them. You got your macros here, your local apps, lookup table files, node scripts. See anything else prominent? Syslog, source types, all that stuff now is done for you. So once that's done, all you do then is basically just go back, take out the debug refresh, and then it gets you right back into where you're at. Any questions about that? All right, cool. So let's look at Patrick's index. Index equals Patrick underscore index, and then let's hopefully our field is populated. Let's stop this quickly. Actually, let's do add. Let's do. So let's be a little bit more efficient for what we want. Then now we see what we created, our packets in. This is the new fields that we created, our packets out. And then we have our sum bytes here, but we call it total bytes. And then, yeah, so we created these three fields, our sum bytes, our packets in, our packets out. So what you would do with this is you would create these same aliases across all your data sets. So if this is called some packets in here, but let's say in another different data set, for instance. So let's do another data set so it sort of makes sense. All right, so let's go to, who else has like, so let's do that so you guys can see. So we'll do metadata. Actually, we'll do tstats. This is whenever you want to see the kind of data you have in your environment based on the index. Tstats is best for that. If you want to just see like the source types or source or host, metadata is the best for that. So we're going to do tstats count where index equals star I. We're just going to do source type because we want to see the different source types. And I can usually tell what kind of source types will have the information I'm looking for. So we're looking for like stuff that has packets. So let me see. Stat, stream IP, first Linux, PS protocol package, open ports, netstat. I wanted something more like what do you call it? Like network related data, network interface, maybe, but no, that's probably just the interface itself. So let's do this. So, and you can just do index as another field, and what it will give you is basically tell you what index the stuff is in. So again, this is just tstats count where index equals star, looking at all indexes by the source types and their index. You can also include source or host as well if you want. So what I would do here then is look for something that, hardware, don't care about that. SOF, that's that. And then stream IP is only Patrick's. I feel like there's another when I did that for us. So let me go back a little bit further. And then this time what I'm going to do is specify the source type I want. So let's do and type equals, I know Palo Alto has this, so I'm going to look for Palo Alto because I know what Palo Alto source types are. It's usually pan something. So I'm going to do, let's do all time. Let's see where that's at. Okay, so it's in my open path event gen. So let me stop now so I know where it's at. That's the index we're looking for. So then what I'll do then is just do index equals and source type equals pan star. And then we'll look for pan traffic in this case. So pan, I know the traffic logs always has it. So then we'll run this. Let's do, it's been a while since I got that data. So let me do, let's do actually 20 days. Hopefully that would have it. All right. There we go. Perfect. There we caught it. All right, cool. So remember in Patrick's events over here, we basically looking for like packets in, packets out, whatever. And then we call that to be, you know, his sum is packets in, you know, packets out, some bytes, you know. So what I would do here in Palo Alto then would be something similar. So Palo Alto has bytes somewhere. So you see bytes in, bytes out here in Palo Alto. So what I could do is essentially the same thing. So I can go create an alias now. So settings.
You said Palo Alto?
Yeah, Palo Alto, yeah.
Or where's the Palo Alto traffic coming from? Mine?
No, this is an event gen. I have a event generator.
Oh,
Yeah, it's been a while since I activated it, but it just simulates events into my environment.
okay.
Let's see. So we got field alias. So we're going to do is going to add another new field alias. I should probably just click that. So we're going to say, I'm going to put this in front of the app again. So everybody has access to that. So we're going to say, hello, Alto alias. Again, that's just an arbitrary name I use. You can use whatever you want to use. So we're going to say, and you don't have to apply to a source type. It can be a source or host. Typically, folks apply to a source type because it's usually unique. Sources can be can change. You know, if the source is like a file, and then that file rotates for whatever reason, or that file changes, then that breaks your your convention. Or if that host there's more hosts that are sending rather than just one, then that would break it. So that's why folks usually use like source type, because it's that usually never changes. All right, so for our Palo Alto logs, we know it's pan traffic is the source type that we're looking for. So we're going to say, then we're going to say our alias is going to be, so instead of bytes in, I think it's just bytes in and bytes out. So we're going to say bytes underscore in is going to be packet. Let's make sure we get it right. Packets, yeah, packets with an S. So packets underscore in. And then bytes underscore out equals packets underscore out. And then we're going to save this now. And then same thing, since it's going to be private, I'm going to flip this. This time I'm going to allow everybody to be able to read it. And then you guys are modified admins, so I'm going to allow, if you want to change it, you can change it for whatever reason. So where's my modified admins at? So that's what I created here. All right, so now I've done that. So now that that's done, same thing. I'm going to debug refresh. Close these two boxes. Debug, refresh, debug, refresh. All right. So essentially what I'm trying to do is say, let's say I was looking for data that has packets or information, whether it's packets in, packets out. And I don't want to search by every single source type. So you would include that now in your data model, say in your base search to say, as long as this information has information about packets in or packets out, that's going to be part of my network data model. That's going to be part of that. So what you do then, or what you're essentially doing at that point in time, is doing SIM compliance. So Common Informational Model. So that's what SIM stands for. CIM, Common Informational Modeling. So you're basically saying the information that we have, we're going to model it so that it basically looks the same across all the data sets if it has relevant fields that are the same. So if the packets field is called, packets XYZ in Patrick's index, but there's another index that has, packets related stuff that's called packets ABC, all of it still is the same thing. So we're going to create a new alias for it. We're going to call it, packets, you know, um, packets Y. And then now both of your indexes, when you do a search for packets Y, will give you information from both indexes. So that's essentially what we're trying to do here. So we're going to say index equals path underscore n, because we know what that index is, or index equals Patrick index. And then we're going to do packets underscore n equals star packets underscore out equals star. So what this should do, if I search for last 120 days, because we're trying to include the data from OpenPath Event Gen and also Patrick's, what this should do essentially is, then we'll do time type. What this should do then is it should basically grab data from both source types. It should go back to the point where it sees what do you call it? Palo Alto stuff. And perfect. So Palo Alto stuff popped up. So now we see that. Now we're basically looking at packets in from both of these source types. So now it's basically doing that. So it says, hey, the packets that are been coming or packets out, there is 64,000 and counting events from Palo Alto that have packet related stuff. And then there's 30,000 plus stuff from Patrick's index that's coming from this stream IP. Does that make sense, guys? Any questions about that? Again, just making sure everybody's clear. We all good about this? Anything I need to re-explain or go over? All right, you guys got it. It's good. Field alias is a very important part of common information modeling because it's basically how you make information the same across everything, right? So if you have refrigerator data, if you have, firewall data, if you have TV data, if you have computer data, um, if you have your router data, it doesn't really matter because it's still data that's, probably related to traffic events. And if you want to correlate all of those um, uh, events to be the same, so packets coming out of your router, the bytes, it's still just relative in terms of like the language that it's used as your TV. If your TV is communicating to Hulu or to the Netflix servers, or is communicating to, AWS, whatever it is, it's still communicating over basic standard TCP, UDP protocol to be able, or HTTPS, whatever it is, to be able to grab that information that it needs and utilize that. And that's still traffic that can be quantified. So what you're saying then is, as long as this data can be quantified and we can link it together, that's when you get the useful information. So if you're working for a big bank and the bank says, hey, we need you to correlate our information to tell us what's happening in our environment, they literally are talking about common information modeling, where you go in a data model now, you create a new data model called blah, blah, blah. In my case, coronavirus. And then we says, as long as the index equals to whatever index is, we're going to now say as long as the index equals to blah, blah, blah. And then we have fields called packets in, packets out, total bytes, whatever it is that you have measured. We're going to now make that into a small subset of information. So whenever I run a search now, it runs so much faster now because I'm no longer doing index equals blah, blah. I'm now basically just doing a search against this small subset of data. That's essentially what they mean when you have to tune data models and stuff. All right. Data models is very important. Field alias is very important. We'll go over, let's do, what else can we go over? Oh, well, tags, right? So tags is another one, right? So when you click settings tags, you have the option to look at tags based upon the value pair, the tag name, or all unique tag objects. So you're just looking at every unique tag objects. So this one, we're looking at one by the field value pair. So right now there's a tag called client error. So then what that does is it's tagging an event type called client error. So whenever there's events where it looks like client error, it tags that. And then that tag now is basically given a name. So then you can do a search based upon this tag to grab what you're looking for. So let's look at that example. I hope this is helpful, guys. It's only 10 of you in here. All right, it's cool. All right, so let's hide my floaty. So let's do index equals with yours. So now if we look here, right? So you have tag event types. So you have communication tags, you have network tags, certificate related tags, SSL, TLS, web authentication. So all of these tags are done basically at the props level. So when you download Splunk add-ons, they're usually built with tags and stuff so that they can tag your information based upon like similar traffic. Somebody trying to say something? Right. So you can see here, communicate basically is the same thing as network. So it's saying, hey, this guy's communicating, and it will make sense because they're communicating probably over a network about whatever they're communicating. So 100% of these events here are communication events. They're network related events. So if you click here, you'll see how you can search by tag. So you see tag, ... event type equals network, right? So we can do that. Now imagine you try to do tag network. Then we look now at our tags and we see essentially the same thing, right? So you can do this way, or you can do like the actual way that Splunk does the tag, where it does a colon, whatever it is, the actual event type, and then it does the value of whatever you're looking for. You can do that way as well. Either one works. Let me see. I think another one we saw was SSL, right? So yeah, you can do a search based upon that either way that you want to do that. But the beauty of tags is that you can include these now in your data models without having to specify like a unique tag, right? So as long as this tag is something that matches something within your data model. So let's go to data models again. We go to coronavirus, this is the one we've been working with. Then you can see now it's a field that's been added in here. And it's also a tag, right? So as long as this, stuff is tagged or is event typed, you can now pull that data into this specific data model. And the reason why that's important is data models have to be accelerated, means that once they're running, they're basically, think about like a car. When a car is running, it's like it's powered up and it's actively running and it's doing work for you. Wherever you're going, whatever you're driving, whatever you're doing, it's doing work for you. But in order to reload the car with gas, you can either go to a gas station, stop the car completely, or this does not make sense here, or you can actively you know put gas in the car while it's running, which is dangerous, right? So with uh, data models, you don't necessarily put gas in the car while it's running, but what you do is you create tags and event types, which are like a modified, version of like, beefing up the data model to give more information, feeding it into the data model, because you can't just add a field in here. Once you've set the data model, once it's been accelerated, it's accelerated. You have to stop it in order to add new fields. So what people typically do then is basically create event types and tags and then field aliases as well, so that as long as those fields that have been in there are hard coded, what you can do then, you can modify whatever results you have. And as long as it matches whatever fields that you already have in here, it's going to now include that into your events. So like, for instance, if I were to do t-stats, actually, let's do this. Data model. Data model. So the name of my data model is corona_virus, and then we're going to do a search in the last 24 hours. Didn't get anything. 30 days. All right, there we go. So got some. So I don't think I have it accelerated that much. I have to go look at my acceleration again. So data model coronavirus. Coronavirus. So acceleration. So yeah, it's a month acceleration. So yeah, I'm not having this like, and then it's summarized range. So every 15 minutes is when it's doing a summarization. So yeah, it's not running as frequently as you typically run it. So that's why it's not, going back like fast to do like its correlations. So right now, data model coronavirus search is basically looking at all the different fields that I have inside of this data model. So confirmed detail, confirmed value, country, and all that other stuff. So then what you'll see is it does an all underscore statistics dot confirmed detail. Then you'll say, where does all underscore statistics come from? Comes from here. There's a subset of my data model, which is basically called a parent. So it's a parent, what is it called? A parent event that I have where I can basically say, this is what I want for like all of my searches. And then if I wanted to modify it a bit more to be more granular, so, for instance, when I did, index equals, Patrick index, and then we say we want to look at everything that has packets related. So then we can do a subset of that child event. And then what that would say is I want to look at stuff that's related to just this specific source type, that has this specific IP, that has this specific user, that has this specific number of deaths, just based upon whatever you want. That's how you would modify that. So to give a better example, let's go to Buttercup. I think they have a bunch of events. Actually, don't have anything. Useless. Let me see. Somebody that practice. That's Richard's data model. Richard, are you still using this data model?
No, I'm not.
So I'm gonna start data model. I'm gonna unaccelerate. So when I try to add events, see here, this data model cannot be edited because it's so accelerated. Disable the acceleration in order to edit this data model. So now I go to edit, acceleration, then do that. And then now all of a sudden I can edit it. So now I can add events. So then what I can say is I can add so Richard did an index equals underscore internal or index equals underscore audit and then action equals star. So he's looking at basically audit related stuff or internal stuff. So I'm going to restrict this a bit. I'm going to just say, let's look at all audit stuff. So when people log in and whatnot. Okay, so yeah, we have that. So, all right, so we're going to keep that. So then we're going to say, let's say we want to add a child process, right? So child data set's going to be, let's just call it child one. You see gives it an ID, and then inherit from my test data model. So let's cancel this, and then you'll see.
What's a child data set?
Yeah, I'll explain in just a second. So this is Richard's parent data model. This is like his parent data set. So imagine like as a child, you inherit stuff from your parent, but the parent can't inherit stuff from the child because, you know, unless their child has like a bunch of wealth and dies and then gives it to their parent, which is typically not the case. You know, the parent usually dies first. They give the stuff to the child. So what happens is everything that the parent owns, the child has access to. So now we'll do that. So we'll say child one. So then we'll then call this, you know, additional constraints. So additional constraints is you're saying everything that was inherited by the parent is now the child's. So what we're going to say then is action equals login, do login star. So we'll save that. So what happens is you see that it gets basically branched under here. So now it's child one. So basically what happens is once we click this data model that has index equals underscore audit, action equals star, this parent right here passed everything that belongs to it, including the extractions, all that other stuff, it passes on to the child. And then the child then adds a new constraint to say that now we're only looking for stuff that where it has login related events. So then you can even add another child on top of this and say, you know, grandchild one, and then inherit stuff from child one. Then what we can say then is see status equals fail. So now we say, hey, we want to look at all the login stuff, but when it fails. So now look at what happens. So now it has action equals login, and then now it adds a new, constraint. So the constraints basically are saying that it has to include this stuff in it. So initially we're saying we're more open, we're more free over here. And that's the way you typically want to be. Your parent is the most free person that has everything. And as you become the child, you start adding stuff into whatever the parent is giving you, and you constraining to that. And then the same thing, grandchild now has failed. So now we're saying, instead of looking at all login activity here, we're not going to look at all login activity that's failed. And then so on and so forth. And then you can look at the specific user, the specific client IP, the specific countries, the messages that you want. And that's how you would basically tune a data model to give you exactly what you want. And then what happens is when you run a search against this data model, is going to be a dot whatever. So in our search here, you see the first one was all statistics dot confirmed dot detail. What happens is it does all underscore statistics dot, and there's going to be child one dot grandchild one dot the field that you're wanting. And then that's how it works from there. Does that make sense? Or does that not make sense?
Can you scroll up to search?
Yeah, sure. Yep. So let's see if it'll work for Richard's data model. So we'll do edit acceleration. Let's accelerate for maybe a day. See what happens. It may take a while for this to kick in because we're doing audit data. Let's see. So Richard's data model is practice data model. Do a data model search. Practice data model. Let's run this for 30 days. Let's see what happens. So you see here, Richard's data model, my test data model is the first part that comes up. My test data model is what he called it. So then underneath that, we have a is child one. So that's whether it's 0 or 1 is like whether it's like part of it included or not. So if I did this, press 1, which equals true, 0 equals false. So when I do 1 is like all of the events that we have are included inside of the child one. But remember, our constraint for child 1 is that it has to be login related. So that means that if I press 1, that means everything that's going to be shown here is going to be login related stuff. So when I press 1, what you see now is user admin action equals login attempt, login attempt, login attempt. And then let's see, it's still going to be building for a while for that other stuff that we just added. But yeah, this is essentially pretty much like how it works. And then the client IPs it tells you. So yeah, this is you know, a very good but brief overview about just data models. We can't really go in depth. I could probably literally spend like a whole class, not like a single class, but like a whole course rather, teaching about data models, like how to create it, how to modify it, how to tune it up. But for the most part, to creating a data model is very easy. It's when it comes to tuning. So it's new data model, you give it whatever name you give it, and then you put in whatever app you want to put it. And then what happens is it becomes something like this. And then this is what you get. And then you have to add a data set to it. When you're adding a data set, you can do a root event or you can do a root search. Root event is like, this is something that's happened and this is what we're looking for. A root search is I want to look for something that's wider. It could be anything. An event could be encompassed in it or it could not. But what we're doing is just we want to cast a wide net. So we're doing a root search. So we're going to say, underscore whatever. Right? Then now you can do a search for it. So we'll do index equals Patrick underscore index. We'll just grab yours. And then this could be your base search, right? So then you can press to run it, and then it'll tell you, give you a sample of like the events that it's going to pull up. And then you can say, okay, this is what I want. So as long as that's what you want, you could save it, or you can be more granular and then, pick a timestamp, pick a source IP, pick whatever you want to pick, you can include that. But remember, whatever you pick in here becomes a constraint. So now it's a constraint. So whenever you want to create additional stuff that's at the base, is going to be different. But you can also add another root search. You can call this whatever. Hence, then x equals. I don't know if you have anything in your index to me, but let's see. You do. Oh, no. Sorry, I forgot we got that stuff in your index. Sorry about that, Timmy. Let me see if I can do first. No. You guys have so let's do main. So all right, so we have main here. So we'll call this main buttercup. So now we'll do equals do perfmon. Let's do available memory, right? Let's just grab that. Just something silly. So now you see you have 2 root events, and then you can add child events to these guys separately. So you can be really like as granular as possible or as wide encompassing as possible. The danger with being wide encompassing, meaning that you have search that just goes willy-nilly everywhere, is that your data models have to summarize these events, right? So data models, the bad thing about them is that they cost disk space. So if you have data models that are running like, for, I don't know, 3 months, 6 months, whatever it is, if you have data models that are running for that long, the issue is that now all of that data, depending on what you put as your summary or your summarized time frame. So if we do edits, acceleration, whatever you've put now as your summarization period for it to go back, and then your summary range as far as like how far back it's going, and then how, what is backfilling, is going to be the amount of data that you're going to have to now create a brand new storage for. So typically Splunk stores this data in var lib Splunk. except if you put it, whatever, partition or location you want to put it in. You can tell Splunk to store it wherever. That place that it's storing its data in, it's also going to store what's called data model accelerations or summaries. So these DMAs now are now going to cost you additional storage space. So let me show you what that looks like quickly. So look at where my stuff is stored. So actually it's on my indexer. So let's see here. So now this is my indexer. So my indexer is protected from the outside world. So when I have to be able to log into my prod OpenPath before I get to my indexer, and it's only presenting its internal IP. So it's not presenting its external anywhere. So there's no external IP connected. So I can't randomly from wherever in the world access my indexer directly. I have to go through my search head first to be able to do that. So we'll go into actually before we do that, DFSH. So my data, it looks like it's stored in slash data since that's 150 gigs. There's nothing else that's pretty big. Once slash data. I think I have it in Splunk storage. Just do that. I want to delete this thing. It's taking up a lot of space. Let's see. This is here. So yeah, 1.3 gigs. Oh heck no, bro. This is a big file. So we see there's 63 gigs. Why do I have 63 in Splunk storage? Huh, that's weird. So I'm gonna have to figure out why I have two. Anyway, but all right, so let's go into we can do LL star here to see what's underneath here. And then you see there's a data model summary here that we have. So let's do that. So let's do I wonder if I can chain it. Chain it that way. Let's go into model. Gotta go into index first. So let's go into which one do we want to go to? OpenPath. Let's go to OpenPath OS or Vention. Actually, before we do that, let's do this minus CH star. Data. All right, so let's see which one's bigger. All right, so we are going to see which data model has some size to it. Show you on statistics one, so 13 megs, yeah, nothing pretty big. So it's not really substantial. There's 56 kilobytes here. It's, yeah, so this is nothing really big. 132, okay, so this one's still it's not big. So we'll go into this one. So let's go to C. All right, so then you see there's these GUIDs that basically get stored here. So it's the same GUID. So GUIDs are basically like identifiers for your instance, your Splunk instance. So if I were to do a cat Splunk, let's see, CFG. So this is the instance GUID. As you can see here, it's the same GUID that matches this. It's the same GUID ID. So this is saying that this data originated from this indexer. So we're going to go into this guy here. All right. Then as well. It has it. Sometimes you have some empty stuff as well. So let's do a d minus. Okay, all right. So we got some stuff. So this guy has a little bit of stuff in here. So see, there's a data model acceleration for coronavirus. So it has some data that's there. So the coronavirus stuff is really, really tiny. It's not a lot of data at all. But imagine now you have billions of events that are being summarized into a data model. That's going to cost you gigs, if not terabytes. And depending on how fast you're accelerating it, it's going to depend. It's going to determine the cost that's going to, be for your company. So you just don't willy-nilly start, creating data models that go back all time. That's really silly. You don't do stuff like that. Typically, your data models you create or either for 7 days, 30 days, maximum maybe 90 days. I've seen some go as far as back as a year for maybe like, audit related stuff, but that's usually for like compliance related information where you have to have that information fast and readily available. Whereas you don't want to accelerate your data model just to go back willy-nilly. It costs resources for you to run these searches, because what's happening is as you're getting your raw data into Splunk, Splunk is basically saying, all right, we need to create a summary for what's happening here so that we can store this now into our tables that we have, our data model tables, so that we are able to now search across it faster. So, just, review this video again, but that's essentially how data models work. You create root events, root searches, then you tune those root searches or events and add additional layers on top of it to make more constraints. So you'll get questions like that on the test, on Splunk test. They'll ask you, what's a root event? What's a root search? What are constraints? And constraints basically is like, like I just talked about, like how you restrict the search to do whatever. And what are like, what are attributes of a child process. So you can see here, if we created a root search, we'll call this index equals main head 1000, whatever, run this, save it. All right, so then you see here, it doesn't have, other options, but you can do bulk edit to add more stuff into it. You can add fields. And then let's say we want to do auto extracted fields. And then you can either include all the fields that you see, and then it'll give it the same name as it has here, or you can restrict it. And then this is important because they'll ask you this. What are the types of values that can be attributed to these fields? It could be string, a number for like a number itself, and then IP if it's an IPv4, and then Boolean is like if it's yes or no, true or false, and nots, ors. So that's what Booleans represent. So yeah. And then for a child process, if we were to add a child in here, you'll see. Then inherit this from that, and then we'll do equals block, whatever. So save that. So then now on the child process, you see now it's a constraint. It's a constraint based on a child. But you see here, it's a root search. It's not a constraint. So that's a thing that they ask you on a test. I believe it's the power user they ask that. Yeah. So understand that, and then it's the same thing. You can do lookups, regular expressions. You can add it based on GIPs. You can do an eval expression. An eval expression basically is like you creating like an evaluation, just like how we do our evals. And then you create a field name and then what's going to be displayed at. Is it a number, Boolean, whatever? Is this required? Is this hidden? Is this hidden and required? So, this is based upon, just creating like an eval expression. So remember how we did like the if statements, if blah, 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 then, create this as that. So in here, they give you an example of what to do. So in this case, let's say we're going to copy this and then just do call test. This test is going to be a whatever. I'm going to save it, and then now it's a test. So now this is an evaluation. So what it does, it says eval. In the case where the error is 404, and then it's going to be not found, where the error is 500, it's going to be internal server error. So then you're going to see a field called test is going to have either not found or it's going to be internal server error. And that's going to be displayed under the test field. So that's how that works. All right. Data models can be very confusing, can be very time consuming on the job. It's going to take some playing with to get used to it. You have access now to create data models. Please just don't go willy-nilly creating crazy data models that do. And one thing, do not create a data model that does index equals star. Don't create a report that does index equals star. Don't create an alert that does index equals star. That's just bad hygiene to do anything index equals star. Do your best to stay away from that kind of search. Be specific, even if you have to include 30 indexes, include 30 indexes. But if your environment has 60 or more indexes, and then it has like a bunch of data across all these indexes, index equals star could be like the fastest way to destroy your environment if you have data models running against that. That's just really, really bad to do that stuff. All right. I'm going to stop there for a second and give you guys a chance to ask any questions.
I got a couple questions. When you was talking about it's not good to run your data model for, you said at the most 30, 90 days. You said that's a summary. Like where would you do it? When you go to edit?
Oh yeah. So yeah, if you go here, then actually your acceleration. So if we do edit acceleration, and then the range, so you can do.
Right. So that means the information in that data model, it will be the past month for this one?
Yeah, so for the past month, it will summarize that month's worth of information into the data model.
Okay, so will it like have previous information in there as well, or just?
Well, it won't have like summarized information that's before a month, but that information could be included, but it just won't be summarized. So when you're searching across it, it's not going to cost the storage space or the processing cost for you, because all you've told Splunk to do is only look at a month's worth of information and accelerate that month and keep storage for that. Rest of the other stuff we don't really care about, but when you search it, it may still come up, but it's not going to come up accelerated. So your data model will run as fast against the stuff that's over like 2 months, 3 months, or whatever it is. That makes sense?
No. So you're saying you can, when you search, it'll still be there, but
it's not in your summary. So your data model will contain both your raw and your summaries. So in here, it's going to be data that's been summarized for you, right? So it's going to give you stuff that's in this 2.7 megs. If you did your search, it's going to come up really fast because it's only 2.7 megs that it's searching across. But then also what's going to include is stuff from your index equal blah, blah. But that stuff is not going to be stored under data model summary now because, we're here. So that stuff is going to be stored in your indexes, which your data model still looks across because you've told your data model, this is where my information is. So what it's going to do is for the stuff that's accelerated, it's going to say, okay, I'm going to get this stuff to you as fast as I can because it's accelerated. The rest of the stuff, you're just going to have to wait because that's not accelerated. I'm not going to do anything about that. I'm just going to take my time getting that for you. But just know that you can't run fast searches against that data because it's not accelerated.
Got you. So everything that you put into your data model that you want to be accelerated, within the last month, that will come up fast. But if you're searching for something else, it will take longer.
It'll take long. Exactly. Yep.
Okay. All right. My second question: what is I guess like a use case at the job? Like, at the job, when they say, "Hey, can you create this data model for me?"
Yeah. So network traffic is one I mentioned earlier, where they want to see traffic from, all users' laptops, all servers. They want to say, hey, we want to see all users that are logging into specific websites. And let's say that website's a critical website, and they want to see what people are doing on those websites. Or if you say we want to see all users that are downloading information, you can do a search that says index equals blah blah, and you have a field that basically correlates to users downloading stuff. So what you'll do then is basically look across all your data that has that specific field, create that data model based around that, and then look at that and say, hey, these are all the users that are downloading stuff. So then you're running fast searches against that. So whenever they see users downloading, whether it's like malware or malware related stuff, you can say, hey, we caught them really fast. That could be one use case there. Another use case is banking information, right? So if you want to see all banking information related to your executives, to people in HR, what are they looking at, to specific like social security numbers, who's looking at your social security numbers, things like that. That's another use case in itself. It all depends on the criticality of the your job. Well, it depends on the criticality of how your job views that specific data set. If they say, hey, this is information that we really care about, we want to see this very fast, I would typically create a data model around that information. License
Right.
information is also important too, especially with the place I'm at right now. And the place I'm at, it's they care very much about licensing and who's using your licensing. So what we'll do then is create a data model that shows breakdown of licensing by specific divisions, and then based on that, we would categorize that and say, hey, this person or these agencies are using more than they paid for, because they're paying millions of dollars for these licenses.
Gotcha. So pretty much, you just if you want to see the data faster, as opposed to just running a regular search,
Exactly.
that search could take a lot longer.
Right. It's mission critical data typically, and enterprise security runs on data models. That's why ES is so touted, because they run correlation models or correlation searches that are based off of your data models. So you have maybe 60 or 70 different data models in ES at any given time, and all of those have different use cases. So hackers, website information, look at network traffic, look at user behavior activity, if there's insider threats, look at password sprays, look at you know um, uh, locations that people are accessing data from probable sites. So if somebody's in Pakistan 10 minutes ago, and all of a sudden they log in from New York in 30 minutes, so you'll have those kinds of information that's accelerated so that you can search across that fast. And usually when you create data models, it's 90% of the time for security purposes.
Gotcha. And then I guess my last question: and you can also do T-stats with data models?
Yes, that's the essence. It's the essence of data models, is using T-stats. So I'll show you guys that right now, actually. So T-stats. So we already know the fields that we have in Richard's data model, right? We have my data model. Looks like action. So we're gonna go back actually. Let's go back. All right, so we're gonna look at all these fields that we have here. So we're gonna say, mark them down. We're gonna open this new tab. So we're gonna say T-stats. And you can do anything. You can do values. You can do same thing as you do like with any stats, values, list, count, distinct count. You can do any of those functions. So we'll say T-stats count from data model equals then the actual name of the data model, which is going to be practice data model here. Where, and then you got to get the name of the field exactly as it is in your data model. So my test data model IP equals to say this guy, 99 guy right here. Then let's say by action, right? We want to gather by action. So then it grabs that for you. So it says, so what we're doing now is, again, we're doing a t-stats against this data model really fast. And you see the search ran in what, like less than, I don't know, it's 2 seconds. I don't even think it took 2 seconds, but you know, it says it did. So it ran 2 seconds to grab information from this IP based upon the actions that it's done in your environment. And then I'll show you a new, and then we'll do by the actual IP itself. So we're gonna do actual IP. I'll show you guys a new, so then we grab the IP. So then we're gonna say this. So we're gonna do IP location. And we're gonna name the IP for the location that we want. So it's gonna be this IP location, my client IP. Then what that does then is basically tries to triangulate where that IP is from. Hey, that's me. That's got me. So looks like that's me, of course. The 99 got me. So it's saying, yeah, this is Sarletti's IP. You know, from I think I'm only from Georgia, Atlanta at least. And it triangulated me. And now what we can do then, we can map this stuff. So we can do a, we can put this on a map now. So we can do a, you know, who was that? It was somebody's trying to steal my shine. So now we got the geostats count by city. Let's get a map that gives us like the geostats, so cluster map. So then now you can see here where folks are located. But let's say we didn't just want that. We wanted to grab everybody. So just that IP, we want to see where everybody's at that's been logging in. So then, we see people logging. So some people have proxies and stuff, you know. I don't think I have anybody from Fremont over here. Or maybe they were in Fremont at some point in time. I don't know. And most of you guys, you can see, are up in Bowie. Somebody's in Hyattsville. So what I'm going to do is use that's it. Why can't I hate the fact that it has the other. I forget how to take that out. Let me see.
Use other equals false, I think.
Yeah, it doesn't allow you, I think, in here. Use other. Yeah. It only does it with the time chart or the chart. But in here, I think there's a way you can format it where the like the map, I think, could be like 0 or something like that. Anyway, I'll have to figure that out. But yeah, so it basically tells you where folks are located. I don't know why it has that. It still bothers me. But anyway, this is how you can use like the geostats to be able to give you statistics, and you can do it by country as well. Country. Everybody in the U.S., the U.S., the U.S. Right. So, and if I see, go ahead.
I was just curious. When you clicked on visualization, you have some more stuff under there. You click that more. Is that new, or did you add that?
Oh yeah, I added these visualizations.
Okay. I've never seen that before.
The map plus is one I've been trying to play with. It's pretty sweet too. It gives you like the actual count. There's a lot more layers that it does too with it. I mean, it's really, really cool. Which you can modify and format it to look like. I mean, they have so many different like. You can do that.
How did you add it?
Just visualizations from Spunk Base.
Oh, okay.
got the dark mode, got the toner, and then they have like they had one that was like really cool too. But yeah, it's just a lot of options that it gives you, a lot of flexibility to like map out your statistics too. Yeah, so yeah. Anyway, yep. This is yeah. This is what we have. Any questions about that or the IP location command, what it does or how it works? Cool. So let me take off.
Basically, the SIM, the common information model, is centered around data models, right?
Exactly. Yep. That's well, yes and no. 90% of the time, SIM is related to enterprise security, which is built on data models. So you do common information modeling so that everything that you search across is essentially linked together. But the way that you typically search stuff that's linked together is you're not going to do an index equals star. You're going to do a t-stats against a data model that includes multiple different indexes. So that's how that would work. So that's why oftentimes you'll hear that SIM is related to more so data models, but again, it's a lot of it is based upon on your enterprise security and using it in terms of making your data the same across the board. Your customer may not have enterprise security though. You may work for a job that doesn't have ES, and they may say, "Hey, we would like for you to implement SIM in our environment." And one way you can do that, which we can pivot to on base.com, accept cookie, and then we can do SIM here. What it's going to do is going to give me an add-on, Splunk Common Information Model. Dun, dun, dun. And I thought I had this here, but maybe I don't. Maybe I'm tripping. Maybe I didn't add a SIM. I'm crazy if I didn't add that. Let's do. And then you can actually browse it from here too. So, not everything is hooked up to the internet. Of course, on your job, they'll probably dissuade you from logging your production environment to the internet. So what they'll do is probably have you downloading and uploading it. But in this case, I just downloaded it. So SIM is installed. So then what happens is, go to here. So what happens on a SIM level, I think it's one of these hidden ones, isn't it? SIM validator. There it is. Let's say SIM validator. Actually, that might not be one. That might just be the validator. But okay, let's say SIM. Here it is. All right, so we can do the setup. And then now what it does then is basically says, okay, these are the data models that you have in your environment right now. And you notice that before we didn't have authentication, certificates, change analysis, and all that other stuff, right? We didn't have any of this stuff. These are all stuff that's important, very important for what do you call it? For enterprise security. But then now, if we go to our data models, and you see we had 19, now we have 38. So now what it's added now is what we were looking for before are network traffic, network sessions. It adds the web data model, vulnerabilities from spyware, updates, ticket management. There's a whole other stuff. I'm going to delete some of these out. Actually, even use this anymore. Clean up some of these environments stuff. Salon Pekin. I don't know who did this one. Oh, Richard. This guy's just adding data models everywhere. Let me see. Performance. Then Maria, I don't think she uses this anymore. Then exam 2 data. Richard, you're not using this anymore, are you? Some of these. I'll give you time to practice. It's good practice. All right, so data model exams, Bola, not using this anymore. So, all right, so it adds like a bunch of data models that are necessary for you. And then these ones, let's see Sam in a minute actually. So all this stuff now is here for you where, you know, you don't have to go and like build new data models now, right? So the other thing is you can upload data models. So you can actually download data model from here. So if we were to go to network traffic, I can download this data model. And now it's in JSON format for me. So then I can actually upload that now into my environment file. I pick the downloads. I can upload that. If you say, hey, I like that data model that you have. It has a lot of structure. It's, you know, it's perfect for my environment. You know, I run a bank as well. I think that data model will be very helpful for me. You can basically import that same data model into your environment now, and you can do a whole bunch of stuff with it. Just as that other customer's doing. As long as you have the same data sets, you can do what you want with that data model. All right, so now what this SIM app does is it allows you to restrict your data model. So network traffic, right now it uses all of the indexes. So you can say, hey, there's only certain indexes that have network information in them. And by whitelisting your indexes, it makes your data model's effectiveness that much better. By default, all your data models, you see where it says no restriction, they're going to search across all your data, your indexes. So it's every, however long you say that it's accelerated for is running, is going to search across all your indexes for your data sets for that time range. So what you want to do then is restrict that to be only to the indexes that have the relative information that you need. So if you're looking for firewall data and you're looking at index equals, you know, my favorite application, that may not have firewall related data into it. So you may want to just include just the indexes that are related to firewall data to be able to make your data model that much better in terms of performance. All right, any questions about that? All right, so Timmy actually asked me a question about KV stores, and I don't think I really explained to you guys about KV stores. So let me do that, and I'll finish. I think I'll finish off with that today. So actually, I'll finish that off, and then I'm gonna hopefully ask if any of you have actually done. Matter of fact, and I can probably check on my own over here. So let me close some of these things. Open path, open path. Let's take a look at open path user. Yeah. All right, so let's take a look. Mercy, Ernest, Clovis, Elaine. You guys have all been logging in. Proud of you guys. Richard, okay. The rest of you.
I'm searching my data. I don't see my logs coming in. I don't know why.
Where are you searching?
Under my index name.
In OpenPath?
Yeah.
All right, we can check in just a second. But who's that? So is that Clovis or is that who's that? Okay. Yeah, we can check Clovis. Okay, so I do see you're searching here. So you have more searches. What's today, the 5th, right? Yeah, so it looks like, yeah, your searching activities went up a bit. All right, so all right. So again, that's just for today. I know, last 4 hours, let me say. So let's see if we increase this to 7 days of 24 hours. I need to see hopefully every one of you on here. If you're asking me questions about stuff in regards to like what we've done the last couple of classes, and I don't see you practicing on here, I'm more than likely not going to entertain that question as much unless you're actually practicing the stuff on the local instance. You can practice it on your own. That's fine. But most of the searches and stuff that I've done are in here, and you can actually audit that stuff. You can go in here and you can audit like what's there. So, ooh, Onyeka's coming on still. You might have a search that's actually there. Yeah, Mo. So whenever you see stuff like this, people usually have like scheduled searches when they're flatlined. It's across the board. They usually have scheduled searches they're running, but they're not actually logging on. But whenever you see like these spikes and drops, they're actually doing some activity. So cool. All right, so we were gonna finish up with lookups. So let's go to our lookup editor. So you have two kinds of lookups. You have a CSV lookup, you have a KV store lookup. CSV lookup are just, ordinary CSV files. So as you can see here, minimize. So we have a time, this is the field name at the top, the user, and then a request URL hash. So with a CSV lookup, you literally, it's not that hard. It's just literally, we're going to create a CSV lookup now. Call this, my ip.csv. And matter of fact, I may not even need to do that. We'll just look at one that we have. Test, load test, you can test one. Okay, we have a test one, KV window, CSV. Which one's the one that we did? Doggone it. Let me look by, let me see, is there one in front of that? NBA, oops, no, don't need that. User information CSV, maybe this one. Oh, yeah, I think we did do this, yeah. So we did the user information CSV one. So whenever you create a CSV, at the top here is going to be the actual name of the fields. So this is the name of the fields at the top here. And these are the values, of course, that it has for each respective field. So then to search this, you just press open and search, and it's going to pop into this where you're going to say, input lookup, append equals choose, like if you modify this information.
What'd you just press?
So it's open and search.
Oh, okay.
And then now it basically opens up for us. So now you can look at it, do whatever you want to do, and then you can append it to the search if you want later. That's a basic CSV. So if we were doing KV store, so let's say we create a new K. I think there was a test one actually. So when you're creating KV, actually, I'm gonna have to delete this. All right, so we're gonna do a KV store one. So actually, that was yours, Timmy. So I'll call this test one CSV. All right, and then we're gonna put this in front end app. Then we're gonna say the first one's gonna be first value. We're gonna call this students. Then the second value is gonna be age, and then third value we'll call it and then IP.
Does it need to be in CSV format for KV Store?
You said does it need to be? It doesn't. It doesn't need to be. I just do it that way because I'm just used to doing it that way.
Okay.
Yeah. All right. So and then field name. I'll call it. What's the last one? We'll just remove this one. So then this one, we're gonna. I thought we had IP as one. Let's put cider on here. Then we're gonna put for age, of course, it's gonna be a number, string for that one, country origin. Array is literally like a list of events that are like in arrays. I don't know if you guys are familiar with like programming, but arrays are a way for you to like line up information that have several different values. So like name, colon, SAR, colon, street, colon, whatever street he lives on, colon, that could be like an array, or an array could be something like, open bracket, close bracket. Inside the brackets, you have something like, matter of fact, maybe that's the so this could be SAR, that'd be and then you can basically in your array you can say the first is first name, the second is you can do one for one, and you can list it out. That would be more so like in your programming logic, but that's what an array is. It basically has a list of a bunch of values in there that can have multiple different meanings, or it could be related to different values for each of those fields. So, all right, so let's save this, create this lookup. So then we'll say, so it automatically creates a key for you once you do this. So you'll see what happens. So if I do 23, see a key automatically gets created. So this underscore key is basically what it's used to key off of your KV. So when you do a search against your KV, you can modify the keys, and then as you're updating it, you'll see based upon like the specific fields you're looking for. As you're changing it, the keys will change based upon that, just showing you that those identifiers have been modified a bit. And that's how people keep tracks of like keep track of their KV. So let's see. Let's do, yeah.
So what's the KV like? I mean, the work scenario. What is the K? What do we use the KV for?
Great question. So CSVs are for information, or CSV lookups rather, are for informations that typically don't change or static. So like, let's say you have a user's laptop that may not change for a long time. You create a CSV lookup for that. If you have a user's ID that usually is the same, that is not going to change for a while, you create a CSV for that. If you have a last name, first name, if you have HTTP status codes, if you have a specific hospital name, if you have something that's going to be static, you use a CSV. If you have something that's going to be dynamic, that's changing, that's when you use KV. So KV basically is key value store that's based off of MongoDB, which is the database that Splunk uses. And that MongoDB is what allows you to do your updates. So you basically interact with Mongo. So for instance, if I go back here, you see Mongo daemon is running, and then it tells you the database path, data Splunk storage, KV store Mongo. This is where it's located. So and you'll see here basically like the stuff that's created. So it creates a Mongo lock for you, which basically like locks your Mongo DB to be used by specific users. Let's do that. And then we should see here by the root user, whichever user started up Splunk and started up Mongo, it will lock it based on that. And then creates for you like a Splunk key. And then these are the different files that basically edited. I think these are like hash markers. I have to look this up. I think these are hash markers, but I haven't explored this fully actually, so don't want to tell you guys wrong on this piece. And then it keeps a journal for you, and then of course diagnostic data. Then I have not looked into these yet. Never really had the need to, but yeah. But you guys, this is not backend anyway. But anyway, it will tell you if you do like on a backend, if you have access to your backend, just grep for the Mongo DB, and then you'll see where it's running in terms of like its database path. So then let me say my IP is 99.
Can you explain the key part again?
Oh, this part, yeah. So the keys are basically unique identifiers for each row.
Okay.
That's literally, it's just, it basically tells you if something has changed. You'll see that the key will change if something has changed over time. And then trackers of the keys. And then you can store that into maybe another database. You say, okay, when has stuff changed? Like recently, one person that I won't mention has a task of tracking when their changes happened in their KV store and who made those changes. And then they'll keep track of those keys that are changed based on that. They'll run like internal commands to look at that. See 88.
Since this is a dynamic lookup, this probably wouldn't be like during the job. We wouldn't be typing it in. It would be like off of a report or something, right?
So if
It's constantly changing.
yeah, so for KVs, you may have a report that appends to like a KV table, but when you create it, you don't typically create it off of like CLI, like not CLI, but off of like the off of the search part. Yeah, you usually use like a lookup editor to initially create it, and then you may not necessarily put anything in the keys. You may just create the regular format, then you append to it. But there's a way where you can also put that into like a you can search that and pipe that into a KV table essentially.
And that will be using output lookup.
That I'm not sure. So I actually haven't done KV output in a while. So we can Google that quickly. See, store. Let's see. And Rufus has actually been using KV store for a while, so he's not here unfortunately, but that's something he's been doing for a minute. But I usually create my KVs off of what do you call it? Off of lookup editor, or I will create it in on the back end or something, and then based off that, it needs to have collections to be able to function. Matter of fact, I may show you guys. Well, no, it doesn't really matter if you do that or not. It's not back end. All right, so let's hide this. So create store KV. Oh. So yeah, we may have to come back to this because I haven't done this in a long time. Let's see, CSV, the settings, look up to blah blah. Yeah, that key. Yep, we know that. So that's the one way we can do it that I just showed you guys. Frequent to large, configure so look at conf files. So yeah, I'll have to talk with Rufus to see because I usually only do it on the back end, or I do it via lookup table or settings like it's showing here, and then do a definition and a type. But that might be a long way. So I'll have Rufus explain that since he's been doing that more recently than I have, or maybe next class I'll have the answer.
I have a quick question. Oh, never mind. Maybe I should ask it afterward. It's about backend, but just quick. If it's gonna take long, you don't have to answer it.
Go ahead.
So how do you put in the, like, you know how you're editing a lookup file now in the lookup editor? Would you say you would do it? Would you do that in the backend as well, or you're talking about just the appending part you do in the backend?
Yeah. So you can just go look at it. And I'll show you exactly how Smoke is creating it. So exits. So CD. See. See. I created an KV. I think I created a friend, right?
Oh, some lookups.
Let's see. Confirm backup. Let me try to find this guy. So what was the name? What did we call this lookup we just created? Test CSV, right? Still fine for this guy. Let's do dash that dash I name type file I name test one, not CSV. See where you're at. What the? This can't be right. Let's do slash opt-in. Would, oh, this is not saved yet. All right, Ruby, cool. All right. Oh, so when we try to open this in a search, what's going to say it doesn't have a transforms because your KV store needs a transforms to be able to call it. So that's one of the different. So we're going to say, I don't know, we'll call this one, system one. Get transform and then open in a search. What the? It's gonna complain it already created one. Test. It's so annoying. Oh, my pop-up. Got pop-up blocker. All right, so see now it has that. So just like a regular lookup, it looks just like a regular lookup, but it's just the type is different. So let's see if we can find that now. This doesn't make any sense. Where are you at? Oh, bruh. Here. So let's do no. It has to be here. It has to what's my search is wrong? Oh, matter of fact, let's do this is bro.
You don't have to take up too much time. I was thinking it would either be in transforms or collections. I didn't think about lookups.conf. Can you just open one up in lookups.conf, one that's already there?
Yeah, that's what I'm trying to grab the locations. Grab dash. There we go. Oh.
Got it. Oh.
Try test one. Let's just do .csv. So this should be inside of there we go. So you see the collections is created here in front end. I knew it was in front end. I don't know where it wasn't gripping or finding it. Maybe because it's actually inside the file. So then if we go inside this collection.conf here, so here. So in here, you see how it's reflected. Test
yeah. But where's the actual row in the like with the values?
What do you mean, the ones that we created with the user and stuff like that?
Yeah, because you created one row for that CSV. So the actual values, is that recorded in the backend as well?
Yeah, it should be tables. But we'll probably I'll show you that after this once class is
Okay.
up.
All right.
So sorry about that, guys. But yeah, so this is what the KV, what it looks like, and then versus the CSV, in terms of like how it's created. So now, matter of fact, this might be cool for you guys to see. So let's do val. Let's do page. Let's do, let's do 34 and let's do 33. So then we're going to do as always. Then we're going to say And of course, page. All right, and then we're going to say, so we'll just keep this. And then let's do put lookup append equals true. And then I'll put this to underscore 1. All right, so now we've done that. Now let's go back in our lookup. Let's refresh. So, why it's not updating? Hmm. You have to look at it to see why it's not updating. But once you add it, what typically would happen then is it'll literally be like you do a insert row below. It should create a new key value for you, underscore key. Now you can see there's a new key in here. That's what I was looking for it to create that key for us. So that's the difference there. Basically, as you're updating it, you're modifying the stuff, these keys are changing. As these keys are changing, that's what it's giving you. So that's the issue there. But we probably should do another class with just straight lookups. I'm going to see if Rufus wouldn't mind teaching that, because he's been doing that like a lot recently on his new gig. There's updating, there's deleting, there's modifying, there's like changing like values like on a fly. That's all like really, really like good lookup like search queries that I think would be very helpful. But that's something I haven't done in a minute, so I don't want to, try to do that on the fly with you guys here. But yeah, that's one of the main differences. Lookups keep keys to basically give you a track of your values or your rows, and as they get changed, you can see that. Whereas CSV is stuff that's static, you don't really care about that. You'll get that in a power user, I think the power user test, but that's also a common question for interviews. What's the difference between a KV store, which uses a database, MongoDB, versus a lookup, which is just a plain lookup table that gets stored locally into whatever file you have it in. All right. There was one more thing. Oh, yeah. So I wanted to look at if anybody was able to create the dashboards that we'd asked for, or reports based on that. It was an assignment for last class. No one?
You get that on Monday. Yeah, I wasn't able to do mine.
All right, guys.
When did you give this assignment out? To the end of class?
Yeah, Monday. Yep.
A simple login, user login.
Yeah, that's fine. I just wanted you guys to do a report and put it on a dashboard.
I think it's posted on WhatsApp, right?
Yeah. Well, I just go on WhatsApp, but I also said at the end of class though to do that. Yeah, guys, you gotta practice this stuff. And all of you should have your data come in. I only see a few people that have data come in.
Advice such a Maya, I couldn't find it today. I don't know why.
I think I did a dashboard, but I didn't do the report yet.
You got one. That's the stuff that I'll put it. Clovis, are you sure you're sending it to your index?
I'm not sure. Just check. Let's see if you can.
What's the name of your server?
It is the personal something. If you say they have a
Personal PC?
yes.
So let's look at what personal PC is sending it.
How are you able to run a T-stats with this?
It's internal. So all the internal stuff, like all not internal, but all default metadata that's stripped is you can run against like your host, index, source, all that stuff you can do against by default.
Got you.
So host equals personal PC. Is it underscore PC? No, personal dash PC. So you were sending win event logs. You're sending it to main. That's why it closed.
Okay.
So you may want to switch that on your end. And then you got something called reporting events. So let's see what that is. Underscore events. I don't know, it's just reporting events. So let's see what this is. So you have agent detection, success software synchronization. So you got your software distribution. Did you like monitor this or something?
Probably, yeah. Probably in the course of doing it, which when I was doing, I didn't know what I was doing. Just
Okay, no worries. I mean,
you know.
okay, so yeah, no worries. This is here. If you want to start extracting stuff, you can. Like just look at executable that's running, which seems to be all DLL host related stuff anyway. Well, some of it doesn't look as executables.
If I want to change it on my end so that it goes to my index, where should I still go to setting and do it? Or?
Yeah, you'll go to settings and modify the inputs. Make sure you create a Clovis index on your end, and then you just switch it, switch the inputs. So, go to settings, data inputs, and then you look at whatever it's under data inputs. So it'll tell you what you have here. So look at these numbers to see what you're monitoring. If you have 0, of course, you know nothing's there. If you have 1 or 2 or whatever, it tells you you're monitoring stuff. In your case, you're probably doing some monitors or whatever. So you'll change that to be whatever it is.
This one here, I see files and directory, XD events, scripts, Windows. So for local inputs, all right, then forwarders. So I should modify just those on the forwarder, right?
Say that again.
Like the forwarded inputs. Are those the only things I need to monitor, or I should monitor everything?
The forwarded inputs only belongs on my end.
Okay, so then local input, that's one I need to modify and put the.
Yeah. So that's the local on your server. Like you want to modify the stuff you're locally monitoring. Yeah. The forwarded piece is like if you have something coming into your server and you want to modify what that is. Let me see PCAP activity.
All right, so to change, I just need to click on that add. This is the bot that. Let's see.
Yeah, you'll see once you go in there and you'll see like how it has the index and whatnot, and just click on it, and then you should be able to change it somewhere within there.
Okay.
Yep. And then at the bottom there, you'll see what index you want to go to. Play around with it. You'll see like some of the changes if you want to make it automatic, manual from the list. If you want to set like a different host value. That's why I want you guys to get in Splunk and like really play with the stuff, because once you do it repetitively, it literally like it becomes like second nature as you're going through this stuff. You'll forget stuff over time, just like I forgot like my KV store stuff. But once you get back into it again, like, oh, okay, yeah, now I remember this or that. So, but for your assignment for matter of fact, before I even go there, somebody said they created a dashboard of something.
Yes.
Who was that?
Mercy.
Mercy. Okay. So did you create a front end app? What app did you create it in?
Yeah, front end up.
Right. So what's the name of your dashboard?
Mercy.
Oh, the name of your dashboard. Okay. You make it sure. Oh yeah. Yeah. Thank you, Mercy. Okay. Okay. All right, Mercy. What are we looking at here?
I just did the what did I do? Event.
Well, without looking at the search, what is it showing us?
The indexes.
Uh-huh.
I think for the class, right?
Okay. What is
Because
it?
index like students index their accounts.
What do you mean by count of what?
Their indexes, like the indexes that you created for us.
What does the count field represent?
The number.
Yep, the number of what?
Maybe somebody can help me.
Anybody want to help her out? What does 6922 mean here next to main?
The main is the main index. Most of the logs are going in there.
So what's 6922?
That's a count of the logs in the main index.
Perfect, exactly. So is that a count of each word, or when you say logs, what do you mean? Is it like the
The data.
okay, so if I did index equals, the reason I ask you this is because this is literally how you explain data to your clients. Say, in your event count, and your thing is count of events. So meaning if you were to do a search in Emotech _ event gen, there should be 4 events. And events, so that would be index equals so I should see 4 counts of events in here. Actually, I'm sorry. What do I see? 45. That's my time. Yeah, I'm not sure why I saw just 4, but basically what it's looking at is your events. So each event is this. So this is one event, this is one event, this is one event, this is one event. So basically what it's doing is it's doing a stats count based upon the number of events that you have. And that's why it's so weird that this one is showing that it's 47,000 here. I'm thinking, oh no, Oh, that's why. So this is 4 events in prod OpenPath US, but then if you were to do it on each of them, you'll see that we have probably like 47,000 whatever. Yeah, see right here. So these are the total count. So this is on this clock index, your summation. So these are the each count of event. So one block of event or row is one count. So that's what it's showing. It says, hey, you have one count of event out of these indexes. And then this is the index name. And then this is the server that it exists on. So this one exists on your actual indexer. This one is on Prod OpenPath. So let's never create more stuff like this so that you get comfortable explaining dashboards and explaining your search to your customers. Because they'll ask you, say, okay, run a search for me that does this and tell me what that search will give me. And that's literally an interview question that you get all the time. Okay, if I needed you to run a search that tells me the number of hosts that are reporting within the last 24 hours broken down by the host and the source type over whatever, how would you do that? So think about it in those regards and then break it down as you're going through so that you're able to explain that to a customer. Say, okay, I would do a stats count. If I needed to create a new field, I do an eval equals blah. So stuff like that is like what the way I want you guys to think when you're building these dashboards or building these things. This is a good start, Mercy. I like what you're doing here. Edit it, play with it, maybe dark theme, undark theme it, add different inputs. We'll go through inputs on Monday. I didn't get the chance to go through CStat, C-chart, and stuff like that to do summaries, but honestly, I'm not even sure if it's going to work. My summary indexing not working, but those are things that I want you to work on. For Monday's class, everybody should have a dashboard created and be able to explain to me what that dashboard has.
Could you check mine real quick? I think I created it on search and report.
Search and report, sure.
User login.
Hey, Ernest. All right, so Ernest, you want to explain to me what's going on here? Ernest, show me the dashboard here.
Oh yeah, I was muted. Yeah, it was a dashboard of users logging in.
Okay, so what is this showing me on the right side over here?
The count of how many times.
Okay, over what time frame?
Let me see. Still,
So the reason I asked that is because those are all important variables, right?
right.
24 hours, I'm assuming, since you didn't keep off. So this is all stuff that you should have. So you should have a title, logins. So this is what like literally in production environments they want you to have. Explain literally what it is. It could be self-explanatory, but you want to see that that explanation because it's important for the customers. Not a lot of them are going to be able to read charts and just be able to understand it, but you want to have it as dummied down as possible so that it's easier for you to explain. And if you hover over it, you need to be able to explain what this is. So 73%, what does that mean? 22, what does that mean? Admin, user. So we know the user's the admin. 4 counts, 13%. Like explaining all these variables is very important. Ernest, do you know by chance what these are?
No.
Okay. So the 73% means out of 100% of your events.
Okay. Mhm.
So this user is one that encompasses 73% of the logins. So this is stuff that you would want to be able to explain to them like right away what they're seeing and how they're seeing it, and be able to explain that to them so that they're able to dummy it down for themselves and for other users.
Right.
This is a good start, Ernest. Mike, advice would be to add maybe a input, like a time input that makes it dependent, so that whenever you switch the time range, you can search
Hmm.
the time range that includes both.
Right.
Then maybe add some other inputs on there where you can look at maybe specific users or drop downs. If you know how to do that, great. If not, we'll go over that on Monday. We'll start on like dashboarding and stuff, get into like more advanced dashboards and stuff like that.
Sounds good.
Good job.
Hey, so can you look into why I can't see my log coming in?
Huh?
Because last time we did it was reporting, but tried searching it today, it wasn't reporting.
Who's that? Who's talking?
Alan,
All right. Okay. So is your host still sending data to the Splunk?
I tried searching it, it looks like it's no longer sending. Or,
Is Splunk running?
yeah, it's running. I restarted it.
Okay. So what's the name of your host?
N-A-N-J-N-G.
So looks like you're still sending stuff. Yeah, you're still sending stuff. I mean, it's just it's in Maine.
Man, I think I changed it still.
Yeah, you're still sending stuff around. It's going into so you just have to change the index if you want to send it to your index.
Let's see.
You got it?
Yes, I just go to the full instance which I installed for Splunk, right?
Yep. Go to that, and then just like I was showing Clovis, go to data inputs, look for what you're monitoring, and then from there you just change the index path that it's going to. If you
When,
don't,
when I go there, when I search, like right now I'm on the full instance which I install, and I go to search that data inputs, and
okay, share your screen quickly.
you see my screen?
Yep. All right. So
I'm doing wrong.
are you?
Because initially they did it by my on my home PC through my Windows.
This is a Linux box, bro. This is not.
Yeah.
Yeah, this is not what you're sending. So if you go to help at the top there, about, that's not the same server. You see INDX1?
Yeah.
That's not the same server. So it's local host. That's your issue here. So go into your web thing over here.
yeah.
Yep. Yeah, localhost 8,000. Whenever,
Local.
yeah, whenever you install something locally, just do localhost and then whatever port that thing runs on.
Localhost.
8,000.
8,000, right?
Do HTTPS in front of it. And with Carry, the local host is a full Splunk instance, right? It's not a folder, right?
I think it's a full instance, which I did.
Okay, try this then. Let's see if it'll work. The colon. Don't forget the colon.
Yeah.
Well, no, it's going to be before HTTPS colon. And you need to copy that inside of the URL. So copy all of that, put it in the URL. So it may not be a full instance, to be honest. So go to your folder down there at the bottom, your yellow folder directory.
Just,
Looks-
so, what folder?
yeah, so you see up there it says Splunk Universal Folder.
Oh, yeah.
It's a universal folder that you have. So
I'll do it. I'll do it again.
oh, so you're going to install a full instance?
Yeah, I'll do it. I'll redo it again.
Okay.
Yes. No, I'll send you a text.
Yeah, just make sure you uninstall that folder because it's going to use the same port. It's going to bind to the same port.
Okay.
Okay. All right. Well, that's it for class today. Timmy, let me show you what you needed quickly. The rest of you guys, if you want to leave, that's great. If you want to stay, that's fine too. I'm just going to show him quickly stuff he was looking for. I think. So, the KB store. All right, so we're grabbing for Surely. So it has matches in here for this.
You looking in the back end now for the KV store?
Yeah, yep. Yeah, I'm in the KV store path. It matches it for one of these S files, but I'm looking for the actual data itself. That it's stored in the KV table. Oh, maybe that's should be in the collections. So for those who care, remember when I had to do the transforms for me to see what I needed to see, where it's at. So this is what gets created here. And sure should be in my KV store too. Jamming back there. I have to add my password in here. User, okay. Let's edit your role, maybe. Keep saying unauthorized. Are you about to drop off? This guy. Even when I'm doing this for you, dropping off. All right, so big guy Timmy's is dropping, but if you guys want to stay, this is fine. I'm actually going to stop recording. And then